Today, I'm going to teach you about the power behind AI, an easy breakdown. I'm Takashi. Let's dive in. Welcome to Alien Tech AI, your virtual hub for unraveling the tech driving our future. Aimed at adults who love digging into the nuts and bolts of innovation, we're zooming into the massive energy needs of artificial intelligence. Think buildings, servers, and the power plants shaping this revolution, including some big moves by Mark Zuckerberg and Meta. Ready to unpack this? Let's go. First, why does AI need so much power? AI systems, especially large language models and generative tools like ChatGPT or Meta's Llama, rely on intense computing to process vast datasets and learn. A single AI query can use up to 10 times the energy of a Google search, around 2.9 watt-hours, while training a model like GPT-3 consumes energy equivalent to 130 US homes over months. This demand is exploding, with data centers projected to consume 12% of US electricity by 2028, up from a fraction today, driven by AI's growth in business, research, and entertainment. So, what kind of buildings house this power-hungry tech? These aren't your average office blocks. AI data centers are sprawling complexes, often covering acres, like Meta's Hyperion project, which could span a significant part of Manhattan's 59 square kilometers. They're designed with reinforced structures to support thousands of servers, advanced cooling systems to manage heat, sometimes using millions of gallons of water annually, and robust power infrastructure, often built near energy sources to minimize transmission losses. For example, Meta's Prometheus data center in Ohio will feature on-site natural gas plants, while others, like Google's planned nuclear-powered sites, prioritize proximity to stable energy grids. Inside, the layout is a marvel. Rows of server racks packed with GPUs and TPUs, the high-performance chips that crunch AI workloads, all wired into a network that hums with terabytes of data. Now, let's talk servers, the heart of AI power. These aren't your home PCs. They're specialized machines, often powered by NVIDIA H100 GPUs, or custom silicon like Meta X S-Training and Inference Accelerator. A single data center might house tens of thousands of these, with Meta boasting over 340,000 H100s by the end of 2024, enabling trillions of calculations per second. Servers are stacked in climate-controlled racks, connected by high-speed fiber optics, and backed by redundant power supplies to avoid downtime, critical when training models that can take weeks. The scale is mind-boggling. A 1 gigawatt data center, like Prometheus set to launch in 2026, could deliver over 3 billion teraflops of compute, rivaling the output of entire research institutions. But this power comes at a cost: energy. A 1 gigawatt facility matches the output of a large nuclear plant, enough to power nearly 1 million homes, and Meta's 5 gigawatt Hyperion project could scale to 5 times that. This isn't just theoretical. AI's energy appetite is straining grids, with the PJM interconnection serving 13 US states, facing a supply crunch that's pushed electricity bills up 20% this summer. So, how are we meeting this demand? Enter the power plant boom. In the US, tech giants are turning to nuclear and gas to fuel AI. Microsoft's deal to restart 3 Mile Island's Crane Clean Energy Center by 2027, with 800 megawatts, and Google's order of small modular reactors from Kairos Power, starting in 2030, signal a nuclear renaissance. Meta's also in the game. Zuckerberg announced Prometheus, a 1 gigawatt center in Ohio, powered by 200 megawatt natural gas plants, with a second planned, and Hyperion, a 5 gigawatt Louisiana complex, both ramping up by 2026-2027. These projects leverage existing grids and new builds, like Constellation Energy's Clinton plant deal in Illinois, where Meta secured clean energy attributes to offset fossil fuel use. Gas plants are faster to deploy. Meta's Ohio facilities target 2026, while nuclear offers long-term stability, though delays, like rare B issues stalling a Meta nuclear plan, show the challenges. The trade-off: gas emits carbon, clashing with net zero goals, while nuclear faces regulatory and environmental hurdles, but both are critical as renewables, like solar and wind, at 24% of data center power, can't yet match the 24/7 demand. The future of AI power is a balancing act. With demand potentially hitting 123 gigawatts by 2035, 30 times today's 4 gigawatts, companies are exploring innovations. Small modular reactors could pop up near data centers, cutting costs, while geothermal and fusion projects, like Microsoft's 2028 fusion deal, hint at breakthroughs. Meta's also eyeing nuclear for the 2030s, seeking proposals to power its AI push sustainably. But it's not just about plants. Efficiency matters. New server designs and AI algorithms aim to slash energy use, while water cooling tech reduces waste. The impact? Communities near these projects, like Newton County, Georgia, where Meta's center strained water supplies, or Ohio, where gas plants will draw local resources, are feeling the pinch, raising questions about equity and energy costs. For adults like you, this is a front row seat to a tech energy fusion. AI's growth hinges on these solutions. What's your take? Should we push nuclear harder or innovate greener tech? Drop your thoughts in the comments. Thanks for joining me on Alien Tech AI. I've loved breaking this down. Want more? Hit that subscribe button and ring the bell for our next deep dive. Ask me anything. Will AI outpace energy growth? Or what's next for Meta? I'm all ears. See you next time. Keep exploring with Alien Tech AI.